You have arrived at gotomath.com if you don't know that already. Let's go down. We're looking at some calculus, and we are actually focusing on the second derivative test at 11-2. That'll be what we're looking at. It says use the second derivative. Call it the second derivative test. It says find all relative extrema. Now we did this earlier, but we did it using the first derivative. So we're going to use it, we're going to find relative extrema, but we're going to do it using the second derivative. Here we go. We got f of x equal to negative quantity x plus 1 squared plus 1. And of course you can tell by just looking at the graph here, lower it a little bit, where that relative max is actually occurring. Okay, it looks like negative 1, 1 right here. But we're going to do this mathematically instead of just looking at a graph. Okay, x plus 1 quantity squared plus 1. Right, so can we remember that? X plus 1 quantity squared. Clicked on the wrong thing. So we have f of x is equal to negative x plus 1 quantity squared plus 1. Okay? Now what we'll want to do is take the first derivative, and we end up with x plus 1, subtract 1, take the derivative of the inside, bring it out, but it's just 1. Of course, derivative of 1 is 0. And then we're going to go ahead and just find the second derivative while we're moving right along. But you know what? In order to do that, let's distribute this negative 2 across, minus 2. Right? And then we take the derivative, we get negative 2. What we're going to do now is just draw this number line, take our critical number. Now remember, it was coming from the first derivative, and we set that first derivative equal to 0, and we're going to actually set this part, this one here, equal to 0. So what is it? And of course c, which is our critical number, is negative 1. Okay, because negative 1 plus 1 is 0, da da da. Alright, so negative 1. Now what we can do is just take negative 1 and plug that into the second derivative. So f double prime of negative 1. And of course, remember, all we care about is if it's positive or negative, but there's nothing to plug it into, so this is going to be equal to negative 2. So no matter what number we plug in here, right, evaluate this second derivative at, it's going to always be a negative number. Negative, what does that mean? It means it's concave down at that point right there, right? It's concave down. Well, it's going to be actually negative at any point on the number line. So concave down, and what does this mean? This means that the function at that point right there, if it's concave down, then this has to be a relative max, a relative maximum at this point right here. So the relative max, and since we're writing them as points, it's going to be negative 1, and then you would take negative 1, plug it in, and we'd end up with 1. But just to clarify that, I'm going to just do this. Right, okay, but f of negative 1 is just 1. Okay, so relative max, that's it. You know, if you're down to the second derivative, you need to determine if it's a relative min or max. You can just plug that critical number into the second derivative and you're done. Alright, instead of finding all that increasing, decreasing stuff. Okay, so we said it was at negative 1, 1, isn't that what we said? Yeah. Okay, let's go up here, make sure the script is all correct. Relative maximum at negative 1, 1. So at this point, if you've been working all these problems going up through here, you should be getting a fairly good grasp and finding out that the second derivative is not just finding out if about concavity, but you can actually determine if it's a max or a min at that point. All right. Okay, well, come on by, go to math.com, check it out, and maybe we shall meet.